All attendees are in listen-only mode.
Hello everyone, my name is Marc-Antoine Lamontagne. So welcome to this webinar on capacity analysis, which is new capability introduced in iBwave design in release 8. So just last week we released that new version, and we're really proud to come up with this new way of managing capacity in a complete HetNet environment. So with what we've done, you can now create a project that combine multiple cellular services and Wi-Fi all together and determine your traffic requirements and how it's going to meet the expectation of your customers on every of these services. So all of that can be combined all together. So that's going to be the topic of today's webinar. I'm going to start with just a few slides just to explain the concepts behind what we have done, and then we're going to dive into the software. We're first going to look at a simple project just to get going with the new concept and how it works, and then I'm going to show you a bigger project, or let's say a more standard venue, which we have done with and how capacity will apply to it. So so the reason we've decided to spend some energy on capacity is really the fact that the need for capacity continue to increase. As you know, the mobile data traffic continue to grow exponentially in the market, and it's becoming really critical for the business. If you take, for example, a retail company, you're going to see now machine-to-machine communication running on Wi-Fi or on cellular. You can think of Amazon with their robots walking around the floor to transfer packets. So imagine if the mobile communication fails at some point and you cannot reach the throughput expected. So you can take also an enterprise environment. Now most workers are running around with laptops. When they go to conference room, they need to have access to webinars and so on. So again, the need for mobile traffic is critical to the business, and you cannot work without it. So for that reason, we wanted to have a way in iBwave to validate very precisely if you are meeting the requirements for your projects, and this in a HetNet world where you can have people running on LTE, HSPA, and Wi-Fi all at the same time, which complexify a lot the analysis of capacity. So from here, I'm going to show you a bit what we have done. So if you look on this slide, you have a floor plan for a small office building, and the way we manage capacity now is, first thing, you have to define precisely the traffic that you have in your venue. So the way it works is that you can define precisely the traffic that you're going to have per floor. So you can provide the number of people on each floor that you need to support, and that number includes people regardless of the network that they are using. So you just, when you speak to the building owner, it's easy to get rough numbers in terms of people in a venue. And then what you need to do is to assign a profile, which is going to define the type of application that people will use. So in this case, we're assigning an office profile. And then you can define also what's going to be the split between cellular and Wi-Fi for these users. So it's never 100% cellular or never Wi-Fi, so you can specify that depending on the environment. And next, very importantly, no venue will have the same requirement everywhere in a venue. So what we wanted to add is also the ability to define specific requirements for zones in your venue. So in this case, you have a cafeteria here that is defined with 40 clients. And if you look at the configuration, again, you can specify the number of people, the user profile, so the requirement in each zone can be different, and also the split between cellular and Wi-Fi can be different, because let's say in a cafeteria you might have people using their smartphone during lunch, and they may not have access to the corporate Wi-Fi at that location. So that's why we wanted to have the flexibility to define that split differently. We also have a conference room here. So as you can see, the definition of the traffic is very granular and allow you to give to provide just the right amount of capacity where it's needed, and not necessarily over designing your project just to make sure you're okay. So you can handle those hotspots as part of your design. Very importantly as well, what we've added is the capability to combine all together multiple services in the same project. There's a lot of projects where multiple network operators are providing services, and on top of that you always have a mix of technology. So if you look at the example here, you have two network operator, in this case AT&T and Verizon, and each one will have two services, one on LTE and one on HSPA. So a very standard, let's say, type of deployment. So what the application allows you to do is to define the split first between the two operators. So in this case, 50% each. So this is based on market share in special regions, for example. So you can get that information freely from network operator. And then what you can do is also set the adoption for the different technologies. So on different operators, the adoption of LTE services might be a bit different. So you can specify what's going to be the split between LTE and HSPA, and so on. So that split can be different depending on the network provider. So this is for cellular, and on top of that, you might have a complete HetNet design where you also gonna deploy a Wi-Fi system. So in that case, you also want to define your split between 2.4 gigahertz and 5 gig. So again, you can define that. So the beauty of that is, from a design perspective, what you need to specify is the number of people to support in a venue, which is normally very easy to do, and then we're going to take care in the background of allocating each user to the right service based on the splits and configuration that you have set. On top of that, also aligned with the HetNet mentality, now we have a full modeling of VoLTE and voice over Wi-Fi. So for each LTE service, you can also define if that service provides support for VoLTE. In that case, it will use, every voice communication will go on LTE. If it's not supported, then it will be routed to the 3G service for that same network operator. When it comes to voice over Wi-Fi, it's a bit the same concept. So for users that are assigned to this service, if voice over Wi-Fi is enabled, the traffic will be automatically transferred to the Wi-Fi network. So you just need to check these boxes to decide where the voice calls will be routed, and we're gonna add the users to the right service and account that for capacity validation. So at the end, what are you going to get with the software is first a capacity map, which gives you a very in a very simple way a capacity map that tells you if you are meeting your capacity requirement in all regions of the floor. you can, if it's green, it means it's good. If it's red, it means that you have a problem. And what we validate in terms of capacity is two things. First, we're going to make sure that you have enough air interface to support the capacity. So based on the bandwidth associated on the channel that you're using, you can support a certain amount of traffic. So this is the first validation. And then the second validation that we do is to validate the number of simultaneous connections supported by the equipment. So if you use a specific model of small cell or Wi-Fi, we're going to validate that it doesn't go above the defined number of connections for these equipment. The second map that we've added in Release 8 is the average data map, which is going to give you a precise view of the data rate available per user in a venue. So this is very different than the maximum achievable data rate that we have today, which gives you the data rate that you're going to get if you are alone using the network, but the reality is very different. You have interference, you have people sharing the same network around you. So the average data rate will be the data rate that you can expect per user based on the traffic that you have defined in the venue. And this is going to be very precise. It's going to give you a value in every location on your floor. And then lastly, we have added the capacity as part of the compliancy report. So this report is very useful when it's time to review a design and making sure that it complies with all your requirements of coverage, throughput, SNIR, and so on. So, so for each one, you can define your target requirements. So we've added capacity as part of the same report. So in one view, per technology, you can see the results per floor if it's passing or not. So in one report, you can make sure that everything is fine when it comes to all your network KPIs that you want to follow. So these are all the slides that I wanted to show. Now I will jump into the software to show you how it works in practice. So I'm going to start with a very simple project. So this is an office floor that we have here. If I look at it in 3D, what you're going to see is basically that you have this floor plan, you have all the surrounding of the building in concrete, and in the middle you have multiple offices using drywall material. So that's what we have to work with today. And everything is already modeled, so it is scaled, all the walls are there and everything. So we are ready to start a design on this floor. So I'm going to start with the automatic access point placement. So what I'm going to use is a small cell deployment where I combine 4 services: LTE, HSPA, 2.4 Wi-Fi, and 5 gig Wi-Fi, all together in the same access, in the same small cell. So let's use the automatic access point placement. And what I'm going to do, I'm going to simply use a generic small cells that I have in our database. So if you look at it, you have the 4 services that are there: 700, 2.4, 5 gig, and 1900 HSPA. So all of these are defined, and what's important to know is that you have, as part of the database, it comes with now an equipment limit, which defines the number of connections supported by that small cell, and this number is to be set for every service. So in that case, for every service supported by the small cell, the value or the limit is set at 32. Some manufacturers will support higher value that can be enabled via licensing. So what we have done is along with these manufacturers, we have set in the VEX file a default value that can be used when you use those parts, but you can still change that value manually after the fact if you need to support a higher number of connections. So that's going to be the small cell that I'm going to use, and I'm just going to run the automatic placement on the floor just to see what we get to start, and I'm going to apply and close. So I have an initiated a first design here, and then I'm just going to run the Wi-Fi channel assignment to make sure that on Wi-Fi I don't have any overlapping channels. So I have an initial design here. I'm just going to move this over here to make that a bit more realistic. So now, just before I start running some prediction maps, let's look at the requirements for capacity. So what we have here is an office building, and we have 100 people to support in that floor. So the place to define that is in project properties. And now there's a new section called capacity requirement. And here you can set per floor, we have the number of client that you want to support. So in this case, it is set to 100. And then you can set the user profile for that floor. So in this case, you can select from the default profiles that comes with iBwave. So by default, we came up with a list of common profiles for common venues that people normally use. So so you can use them freely if you need for your projects, or you can define your own as needed. And for each profile, there's basically an average throughput per user that is defined for cellular, and the same thing for Wi-Fi. So I'm just going to use the office profile in this case, and then lastly you can define the split between cellular and Wi-Fi. So this is an office building. Most communication will be done using the corporate Wi-Fi in this venue, but there's people still using cellular on their personal phones or tablet once in a while. So we've allocated 20% to cellular on that floor. And then we have another section called capacity definition here, where you can set your market share configuration. So what we have here is the configuration first for cellular. So for the two services that we've discussed, 700 LTE, 1900, you can set what's going to be the split between those two technologies. So in this case, I have allocated 60% on LTE and 40% on HSPA. And then for Wi-Fi, you also have that split. So I have allocated 80% of my traffic on 2.4 and 5 gig. So these are defined. If you want to go more granular, you can even define the type of UEs that will be used in that venue. So you have the split between SISO and MIMO devices. So you can play with that or use the default values. And in this section, this is where you can define the usage profiles. So as I said, we have default configurations or different default profiles that comes with the software. Those come from existing users that were using those kind of profiles through a spreadsheet for capacity calculation in the past, and also from scientific research also, where we got those numbers. So there's a lot of let's say science and validation behind those profiles, so you can use them freely. Or if you have already some of these profiles defined internally and you want to keep the same configuration, you can also do that. So if I take, for example, the office profile that we have here, basically it's very granular in the definition, so it tells you how many emails you're going to send, how many web page you're going to open, how many phone calls you're going to make, and so on. So for all the different types of application, you define the metric and all that for a reference period. So for each profile, the reference period could be different depending on what makes sense. So in that case, it was easy to say for an office worker, let's take 8 hours as a reference because of working hours. And during these 8 hours, what is the typical usage for an office worker? So it tells you how many minutes of phone calls and everything is done by user. And that at the end will give you a total, let's say, data used by a user. And if you bring that back to 1 second as an average, it gives you an average throughput to support per user. And you have the same thing for Wi-Fi. So a profile can have a different value between cellular and Wi-Fi, because for most people, if you use Wi-Fi, you're normally going to use more data just because it's free and it doesn't come into your data plan. So so you might end up with more throughput when a user is running on Wi-Fi. So again, you can create your own profiles and add that to the list if you want. So what's important to say in terms of configuration, what's in this section here, the market share, the user profiles, these are part of the templates that can be saved in iBwave. So you can define once your market share and all the profiles that you use typically, save that as part of a template, and then use those on multiple projects. What is unique to a project is the section here on capacity requirement, where you need to set the number of people to support in the venue and the profiles and the split between cellular and Wi-Fi. So these have to be set, and that's normally the only place that you need to go on a new project, because most of the market share configuration and profile will not change too much from project to project. So now that we have this defined, let's look at what we get on the software when we start running the maps. So all the maps are already pre-created for these 4 services. So first you have, well, let's run first. So as you will see now, there's a capacity map that is added and an average downlink data rate. So as I was saying, you can first start with your coverage requirements at first and see what you get. You can also see the other maps to see per technology what's going to be the, let's say, the best server or best AP to know which AP is going to be used in each region of your floor. So let me just enable here the sector number here for HSPA and LTE, just to see how the automation spread those small cells on the floor plan. So with the algorithm that we have, we just give the right amount of small cell, but also we filter the services. So we basically disable some services on some small cells to make sure that we're not overloading the network when it's not required. So obviously on 5 gig Wi-Fi we have 4 small cells with 5 gig, but as you will see here on 2.4, only 2 of those small cells will have 2.4 active, and for HSPA and LTE only this small cell will provide service. So this is what we have to start with. Now what I'm going to do is to look at the capacity map. So I'm running that for LTE first, and what you will see is that it's pretty much green everywhere. So it's providing enough capacity to support what we need. And again, the criteria for capacity is to look at the air interface and the equipment limit as well. So we can track these problems here. So we can see the results for each of these services. So on HSPA we're good. On 2.4 we have a problem with the equipment limit, and on 5 gig, if I run it, we have a bit of a problem of coverage because there's sections where we don't have enough coverage to provide service in those regions. When it comes interesting is when you start digging down with the probe to understand what is happening. So I'm just going to enable the probe on LTE 700. So once you do that, this probe will give you a lot of details in terms of traffic and capacity compliancy. So the first thing you're going to look on the probe is the cell load and the cell load limit. So the cell load limit is what cell load you are designing for. So we typically use 50% on cellular services as your target limit. And the cell load currently on LTE is 0.09%. So basically on LTE we have plenty of room to support the amount of users that we have, and underneath on the probe you're gonna see exactly the number of people that are to be served on LTE. So the number of clients in this case is 12. Where does that 12 number comes? It's basically those 100 users, and then we have a split between cellular and Wi-Fi, and then we have a split between LTE and HSPA. So it ended up being for LTE service 12 users to use LTE services during that time, and the limit of user is 32 as we have seen on the configuration. So we are good to go also from an equipment perspective. If you look below, then we talk about data rate and throughput. So the target throughput that we have defined as part of the Office profile was 3.45, which was pretty low on LTE. And because we have plenty of cell load or air interface available to serve on the LTE channel, we basically boost the average data rate per client at 1.84. So my traffic requirement is 3.45, but at the end I am able to provide to my customers an average of 1.84 megabit per second. So this LTE network is very good here. Now I'm going to show you what's happening on 2.4. So what I have here is a problem with the equipment limit. So if I look at the probe again, I'm going to see the details on 2.4. So what I have here is in terms of traffic, I have 46.3 clients to support, and my equipment limit is 32. So this is covered by the AP0, and if I move to this section, I am covered by this AP1. Therefore, in this case, I need to support 17 clients, and I have a limit of 32. So in this section, I am green. So visually and very quickly, you can see if you have any problem. Let me just enable the ID of each AP. It might be useful after to relate to different AP. So this is what we have. Now I'm just going to complexify a bit the design. So as I said, this is the configuration that is assigned to the floor, but now what we're going to do is assign hotspots where we need to support a higher requirement in terms of throughput and a higher number of people. So what I'm going to do, I'm going to use the here the polygon tool here, and I'm going to define two zones in my venue. So I'm just going to define one zone here, and I'm going to assign this zone as a capacity zone. So this will represent a cafeteria that I have in my office, and in this cafeteria I have 40 clients to support. My usage type will be cafeteria cellular, which I have defined, and I will assign 100% of my traffic on cellular in this case. So we assume here that in this company they don't allow personal devices on the Wi-Fi, and everyone in the cafeteria will be using their personal equipment on cellular. So I have 100% of my traffic on cellular. And then I'm going to create another zone in this section which will represent a conference room with also higher requirements in terms of capacity. So I'm going to call this one conference room 1, let's say, and I will define 15 clients. And in this case, I'm going to define a conference room requirements pretty high. So in this case, we want to allocate or dedicate a high throughput for every user to make sure that we're not blocking any business activities, for example. So in this case, on this profile, we're going to allocate 1.78 megabit per second per throughput per user. And we're going to say that on that zone, 100% of the traffic will be using Wi-Fi. So this is strictly used for business application. So I have that defined now on my floor. So now we can rerun the maps to see what we're going to get. So as you will see, we will end up with more problems of capacity. So let's go back to the maps and let's look at the capacity maps. So now if we look at LTE, we are having a problems of equipment. So if you remember, we said that 100% of the people in the cafeteria will be using LTE. So if we look at the probe, now we can see that in terms of cell load, we are at 22% and we have a cell load limit of 50%. So we are good. What's important to know is that on the probe now you see two numbers for cell load and two numbers for number of client. The reason for it, the number on the left is for the current zone, and the number on the right is the total cell load for the complete sector. Because this AP is providing service in the cafeteria and for the rest of the floor, you can see two values on the left different. So just for the cafeteria, we have 22.36% cell load and 24 clients to support on LTE. If you combine the two together, we ended up with 35 clients to support with a limit of 32. So this is why we have a problem with LTE coverage. And when it comes to the zone, the way it works is that we combine the traffic from the zone and the floors all together at the same time. It may be the same people moving during lunch in the cafeteria, but what we wanted is to secure a certain density of users everywhere on the floor, because those 40 clients could come from that region. So we need to continue maintaining our capacity requirement in this section, but now we're adding an extra capacity requirement for this zone. So we're basically combining requirements from the zone plus the requirements from the floor altogether. So what do we need to do to fix this? So basically we need to add more small cells for LTE. So what I'm going to do, right now we have one small cell providing service for LTE. Instead of using this one small cell, what I'm going to do is I'm simply going to move my small cell service to this AP and this AP. So this way I'm going to split basically my coverage between two small cells, and it's going to allow me to support enough users per sector. So what I'm going to do, I'm going to select those two APs. I'm going to add service for LTE. So I'm going to enable the radio, the LTE radio on those two AP. And on this one, I will basically deactivate the LTE radio. So what we have now for LTE service, I have one sector here and I have another sector here on the small cell. So now let's rerun the map to see what we get for LTE. Okay, so now if I rerun, oh, sector 2, so I need to change the sector number here. LTE. All right, so let's rerun again. So now on LTE for capacity, now I am green everywhere. So you can see the traffic now is 7 on this sector, or 31 number of users on this sector. And in this case here, I have 4 clients to support. So we are now fine to support LTE capacity. So now let's move to the other services. So if I move to HSPA, we also have a problem of air interface, and same thing. If here I can run the capacity on Wi-Fi. So on Wi-Fi is it's even more rigid. I have a problem of equipment limit, and here I have a problem of air interface. If you remember, here we've assigned everyone on Wi-Fi with a high throughput. So here we are missing air interface. So it's not a question of users, but it's a question of air interface. And in this section here, covered by this AP for 2.4, I have also some problem, but in this case in terms of equipment. So I have 42 clients to support and I have a limit of 32. So what I'm going to do now is to add more small cells, but on just for 2.4. So I'm going to take this small cell here and this one, and I'm going to assign 2.4 radios extra, and this is going to replace this one. So instead of having 2 small cell providing 2.4, I'm going to have 3, 1, 2, and 3. So I'm going to start with that. I'm going to go to properties. So I'm going to assign here on 2.4, I'm going to enable the radio, and I'm going to disable the radio on this one for 2.4. And then the next thing I'm going to do for this section, I have a problem of air interface. So I'm going to add one more radio on 2.4. So I'm going to go here. I'm going to move this one in the conference room alone. And this one, I'm just going to enable 2.4. So I'm going to, here, this one, I'm going to keep it. And on 5 gig, I'm going to disable the radio. So now if you look on 2.4 Wi-Fi, I have 1, 2, 3, 4 APs that are providing services. I'm just going to rerun the Wi-Fi channel assignment. So now let's see what we get in terms of results. So for 2.4 capacity, so now what we can see is that now we are green on this section, but on this section you still have a problem of supporting the air interface. So if you look at the result here, on the conference room itself, we're at 78.9% cell load. But if you combine those two, we have, if we combine the basically the requirements for the rest of the floor, it ended up being 80.3% cell load or airtime utilization, which is just above the limit of 80% that we have set. So the last thing I'm going to do to fix my problem is to basically reduce the zone of coverage of this AP to make sure that it just provides coverage in this small section. So what I'm going to do is for 2.4, I'm going to reduce the output power, and I'm going to rerun the map. So, and the goal here is to provide coverage in the rest of the floor with this AP here. So just by reducing the scope, if you look at best AP, you can see that the coverage here for that small cell is just in that section. So overall, in terms of capacity, I am now green everywhere on my floor. So there was a bit of back and forth on this just to show you how it works, but what's important to see is that we've been able in one project to combine 4 services, LTE, HSPA, and 2 bands for Wi-Fi, all together on the same network. And the tool has basically distributed the traffic between all these services based on the market share and technology split that you have defined. So all of these calculations allow you to validate that at the end you're going to have the right throughput everywhere. And now that the capacity is now covered correctly, you can also run the average data rate map, which will give you basically what kind of require, or what's going to be the average downlink data rate that you're going to have available everywhere on your floor. So let me just rerun the maps on this. So what you see, for example, on LTE, in the cafeteria, you're going to have 900 kilobit per second available in the cafeteria. For the rest of the floor, you're going to have a 6.92 kilobit per second, which is higher than what was requested in this section. And you have 2.7 megabit per second available here. If you look at 2.4 Wi-Fi, it's going to be even more granular. You can see that in my conference room, where I had a very rigid requirement, I have 1.79 megabit per second of throughput available for each user in that zone. And then you can see the value on the rest of the floor. So I have 56 here, I have 778 here, and then I have 623 in this section of the floor. So at the end, when you're presenting your project to building owners or to your customers, you can easily show them what kind of performance and application that will be supported for the users on that venue. And then lastly, I'm going to show you the compliancy report. So as I mentioned, this compliance report is very useful to to review a design. You can see in one report a combination of all the services, and if it's meeting your requirements in terms of coverage, throughput, capacity, SNIR, or whatever metrics that you want to validate. So in that case, we can see, for example, that on 1900 we are not meeting requirements of capacity, and same thing for RSCP, and so on. So you can see the results for every metrics. For LTE, you can see that we are green everywhere. We are meeting requirements of RSRP, and same thing with capacity. So very useful to review your project. So now capacity is part of the same project. Just to finish on this sample, what I wanted to show you is also if you look at an LTE system and I click on the system configuration, let me just open this here. I'm going to open it from here. So if I look at this LTE service, you have now two parameters that are available for LTE services. So you have VoLTE and voice over Wi-Fi. In this case, it's specified that it's supporting both. So what it means here is that if both are supported, it will first prioritize Wi-Fi. So if you have Wi-Fi available, all the voice traffic will be using Wi-Fi. If I uncheck Wi-Fi, then it's going to be using LTE for voice. If I uncheck LTE, voice over LTE, then the traffic will be moved to HSPA for the same network operator. So very easily you can enable that based on what's supported for a specific network operator. So now that we've looked at that in more details, I'm just going to move to another project just to show you how it can work in practice on a bigger scale project. So what you see here is basically the design for a Notell, which include conference rooms and ballrooms in the same venue. And what we have is a network combining at the same time. If we look at the design, what I have is I have two network operators, operator 1 and operator 2, and each one has coverage with one sector on HSPA and one sector on 700 LTE. So one sector each, and I have also a parallel network with Wi-Fi access point. So pretty standard type of deployment that you're going to see in a Notell. And if you look at the hotel in more details, let's look in more details in 3D. So you have all these buildings here with the rooms, and on the first floor, so if I just go and remove floor 3 and 2, what you can see is on the first floor, you have in this section, you have conference room and a ballroom here, and you have the lobby, which you also want to cover, and you have one pool outside of the venue, for which you want to provide also services there. So in practice, what you need to do is the same thing. You need to create those zones of coverage that you want to support. So I have, let's say, one zone in the lobby. And in this case, I want to support 40 clients. And in this case, I have associated 50% load on cellular and 50% on Wi-Fi. Because it's a lobby, you might have many people coming from outside the hotel and are not yet connected to the Wi-Fi. So this is why the cellular is higher in this section, and we associated a profile called Hotel, which has a requirement of 182. So I have same thing here. I have another zone defined for my conference rooms. So again, I can connect here. So I have my user type called conference room, and I have associated 100 people, and in this case 90% of the people will be connected using Wi-Fi. And same thing here for the pool area. So again, you want to provide certain coverage. So in this case, we have put 30 clients to support. So what does it look like when we look at the different maps? So if you look at LTE, for example, we are green everywhere just with one sector. But if you go on Wi-Fi services on 2.4, then we start having problems of capacity. So the same way you can troubleshoot and understand why I am not meeting my requirements of capacity. So I can enable the probe. And if I go here, I have, in this case, a requirement of 121% airtime utilization with a limit of 80. So I need more airtime than what I need. And also, if you look at the number of clients, I need to support 93 clients on this for this access point, and I have a limit of 64. So this is the reason why it's failing. And if we enable here the best channel map, you can see that this AP here is covering all this region here. So a large amount of coverage for this AP, and it's even supporting this conference room inside the venue. So if you combine all of that together, basically this same AP has to support 35 clients in this room, 21 person around the pool, and then 35 people outside of this in this region here. So this is why we are busting our requirement of capacity. And then same thing here, we have a problem in this location with this AP. So you can see that we need to support 154 airtime utilization based on the throughput requirements that I have here and the 100 clients that I have, and I have a limit of 80%. Therefore, I'm busting my requirement. And again, you can run the average downlink data rate, so you can tell the hotel owner what kind of throughput will be expected by each user. So you can see that in the rooms, I have a very good throughput. I'm between 1 and 4 megabit per second. So the people staying at this hotel should be pretty happy in their rooms. But when it comes to conference room, like for example here, I have just 194 kilobit per second available in this room when it's at full capacity. So I have some problem to fix here on my design. So again, it gives you a very precise view of how the traffic's gonna be distributed amongst the venue and between different network operator, between cellular and Wi-Fi, and give you also the right tools with the probe to troubleshoot and understand where the traffic is going and if you have any bottlenecks anywhere on any of these small cells or Wi-Fi access points. So again, you can run the compliance report and see the big picture and see if you are meeting all requirements for all services. So again, you have one report that you can review and make sure that you are compliant for all the KPIs that you need. So that ends the demo. and what I wanted to show as part of this demonstration. Now I will finish with by going into a few questions that we have in the question box. So unfortunately there's a lot of questions and I won't be able to answer all of them, but I will try to answer the other ones individually on by email for people who were not answered. So if you want to ask any questions, you can use the question box that you have in the panel. So let's start with the first one. The capacity calculation is based on RF, meaning SNIR, ECNO, and so on, but not based on equipment capacity capabilities. So the answer is no. We actually consider both. So we validate the equipment capability and we also validate the RF channel as well as part of that, and we consider the design as part of the validation. So we consider both. The question, are we going to cover outdoor small cells capability planning as well? The answer is no, not on this call. So it's not part of release 8. So it's something that we are looking at from a roadmap perspective, but specifically on a campus type of environment, just like this one. But it's not covered in this call. There's a question here. Let me just go down here. So does this function on capacity calculation takes into account peak traffic volume and peak user throughput? So the answer is no, because, well, let's say it does consider a peak throughput per user, but at the end of the day, not all user will be communicating at the same time. So you have a certain throughput for certain application that is required per user. So if I take, for example, my user profile in this conference room, for example, you can see what's going to be my application that's going to be used. So you're going to have some peak time utilization by each user, but at the end of the day, not every user will be using the network at the same time. So we basically distribute all these all the traffic requirements across the time period to come up with an average throughput requirement per user. So as part of that, so this is based on an average throughput, and this is the reason why you should account in your design as well for some buffer, because you may have periods where you have a bit more people using the network and some other time where you have less. So to account for that, the best is to set your cell load limit at 50%, for example, to have room to grow and room for that kind of movement in traffic. And for Wi-Fi, it's the same time. You can set your your airtime utilization limit in the same way. So this is the best practice to account for these peak of users. So let's see if I can take another one. So there's a question, what would be the recommended next step to now model out in-building dominance over outside macro cell network? So this is not linked with capacity, but what I can answer here is you have a map called dominance over macro. So if I enable it here, let me just close this. If I just enable this for LTE, on the dominance over macro, it basically tells you how much dominance you have from the in-building system over the outside network. So you can see that in these sections you have a very minimal dominance, but everywhere else in green we have over 15 dB of dominance, so we are pretty good here. And this is based on the macro network modeling that is defined here on the map. So we are considering that outside the macro network has a value of -100 just outside of the venue. So this is the simpler way to do, but it could be modeled using also outdoor prediction imported from outdoor macro tools, or you can also run some survey data inside the venue and measure the macro network before you start your design and account for that. So that's the best way to manage the dominance over macro. So unfortunately, that's all the time I have today, but I will follow up for the questions that were unanswered. So thank you for your time, and if you have not upgraded to release 8, I encourage you to do so. You can go to my iBwave and upgrade your license. If you are not yet a customer of iBwave, you can contact any of us at iBwave to get a trial of iBwave design and talk to us about pricing and everything else. So thank you very much for your time, and I wish everyone a great day.